Okay, good day, grade 8s and grade 9s. Today we are going to look at congruent triangles. So previously we looked at similar triangles, and we said that similar triangles is just basically a triangle that's either enlarged or shrunk. So for example, if I have a triangle like this, right, and if I shrink it to the same scale and if I enlarge it according to the same scale, then there is similar triangles. The sides are in proportion and the corresponding angles are equal to each other. For today, we're going to look at congruent triangles. And for congruent triangles, right, it's basically like a person, right, looking at themselves in the mirror or maybe creating some sort of clone of themselves. So it's like a copy and paste of themselves, if you will, right? It's just a duplicate. It's a clone of themselves. So in geometry, congruency is just basically a clone. It's a replica. It's a copy and paste of an image of a figure. So today we're going to specify on congruent triangles. So as you can guess, it's just a copy and paste of a triangle. And there's different ways we can prove congruency. So congruent triangles, they're exactly the same. The corresponding sides are all equal and the corresponding angles will be all equal. So if you think of it, corresponding triangles, or rather congruent triangles, are also similar triangles. But similar triangles are not always congruent triangles, as of course, two triangles, one can be larger, one can be smaller, but congruent triangles are exactly the same. So there's certain conditions to prove congruent triangles. So today we are going to look at the conditions that prove congruent triangles. Actually, there's four conditions. There's four conditions that we have to prove congruent triangles. The first condition is known as side, side, side. That means all three pairs of corresponding sides are equal to each other. The second way, or the second condition to prove congruency is side, angle, side. That means one pair of sides are equal, one pair of angles are equal. No, actually, two pairs of sides are equal, and one pair of angles are equal to each other. The third way we can prove congruency, the third way is side, angle, side. One pair of corresponding sides are equal, and two pairs of corresponding angles are equal. And the last way has to do with the right angle triangle. It's right hypotenuse side. So for today's lesson, we are going to look at each condition of congruency. Okay, so let's look into that. Right, so let's clear the screen. Okay, so let's look at the first condition of congruency. The first condition of congruency is side, 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 and that is abbreviated as SSS. So let's say we have a triangle, right? We have a triangle, and we can name the triangle in a minute or so. And let's copy and paste this triangle. That's basically congruency. It's a copy and paste of the exact same triangle. So these two triangles are identical. But we have to prove in geometry, we cannot just take anything at face value. We have to prove everything. If it's a triangle, we have to prove that it's a triangle, right? So let's say we have triangle ABC. We have triangle ABC. And we have triangle DEF. We have to prove, we are required to prove, right? We are required to prove that triangle ABC is congruent. This is the symbol that we use for congruency, right? It looks like an equal to sign, but instead of having 2 bars, it has 3 bars. The triangle ABC, the triangle on the left, is congruent. It's exactly the same. It's identical to the triangle on the right. That is triangle DEF. So now we write out our proof. as such. Right? Remember, whenever we prove something in geometry, we have to act like detectives, because that's what we are. We have to give our evidence to say why are these two triangles in fact similar to each other, or congruent rather to each other. So okay, this is as straight as it can get. Let's just straighten that up. Right. Okay, so let's look at the proof that we have. We have in triangle ABC and triangle DEF, I noticed the following. I observed the following. The first thing I noticed, right, of course, in this diagram, I need to actually mark some figures. So usually they won't just give you two plain diagrams. They will mark some information that's quite important. So for example, these corresponding sides. Okay, I don't like that color. Let's try something darker like red. Let's say AB is the same size or the same length as DE. The length of AC is the same length as DF, and the length of BC is the same length as EF. So now let's write out our proof. Right, so let's see what color we can use. Let's use this, continue this orangish color. So we can say that the first thing I notice is that the length of AB is equal to the length of DE. And the reason for that is that it's given. Right, when something is marked or indicated on the diagram, you can just write given. It's given that these two lengths are equal. These two sides are equal from the respective triangles. Now, the next thing I notice is that AC from triangle ABC is equal to the size or the length of DF from triangle DEF. And again, that is also given. And the last thing I notice is that BC is equal to the length of EF, and that is also given as well. So what is my concluding remark? My concluding remark is that triangle ABC is congruent to triangle DEF. Right, and by the way, how do I write my final statement? I can firstly see that one pair of corresponding sides are equal, another pair of corresponding sides are equal, and the last pair of corresponding sides are equal. So my final statement is simply side, side, side. Right? And that is the first condition of congruency, side, side, side. Okay, so moving on from there, let us look at the second condition of congruency. Let's clear this page. Right, the second condition of congruency, right, the second condition of congruency, so I'm going to write number 2, is known as side angle side. Basically, if I can prove that two pairs of corresponding sides are equal and one pair of corresponding angles are equal, then these two triangles are identical to each other. It's a clone of each other. And shortened, that is side angle side. So again, when you prove congruency, the two triangles do not have to be in the same orientation. One can be rotated upside down, one could be rotated to the side, but these two triangles are still congruent to each other, right? Because the corresponding sides are still equal and the corresponding angles are still equal as well. So in this case, let us draw these two triangles. Right, let's say we have a triangle that looks something like that. And again, it's just a copy and paste of that. I wonder if this software allows me to rotate, because it would be quite nice. Okay, it does say something about rotation. Let me try to play around with that. Right, so these two triangles, as you can see, I just literally just copied and pasted the same triangle. But I can also flip it around. I can just rotate this. Let's rotate it 90 degrees or 180 degrees. These two triangles are identical. All I did was I rotated the figure, but they are still identical to each other. So the orientation does not matter. It could be rotated 90 degrees, 60 degrees. It doesn't have to literally be next to each other and look the same. That's the point I'm trying to make. But for now, let me just show you two triangles that are next to each other. Quite simple. Right, so these two triangles are next to each other. It's identical to each other in all respects. right? So I have, let's just label our triangles. Let's say this is triangle, uh, instead of using the typical ABC, let's say this is M, N, O, and let's say that this triangle is P, Q, R, right? So what am I required to prove? I'm required to prove that triangle MNO is congruent to triangle PQR, right? So let's write out our proof. Okay, let's write out our proof as such. So the proof, right? Firstly, I have to state my evidence. So my evidence is that in triangle MNO and triangle PQR, I observed the following, right? The first thing I observed, right? Of course, let me just mark the given information in this diagram. I'll do that in white. Let's say that this angle is equal to this angle. Okay, nice. So moving on from there, let's write out our evidence to show that these two triangles are in fact congruent to each other. So I can see that firstly, side MN, let me just write that properly, MN is equal to side PQ in triangle PQR. And the reason for that is that it is given, it's marked on the diagram. The second point is the corresponding angles are equal, is that angle M is equal to angle P. And again, that is given to each other. It's given on the diagram itself in the triangles. And the last point of evidence, I can see that side MO is equal to PR, and it is also given or marked on the diagram. So what is my concluding remark? My concluding remark is that therefore triangle MNO is congruent to triangle PQR. And the reason for that, as you can see, there's one pair of corresponding sides that are equal, one pair of corresponding angles are equal, and another pair of corresponding sides are equal. So in total, there's two pairs of corresponding sides that are equal. So it's side, then there's another side as well, and in between I have an angle side. So the condition of congruency is side, angle, side. So that's the third way in which I can prove congruency. Now, the third way, before I do that, let me just save this as an image very quickly. Right. Now, the third way I can prove congruency right? The third way is side, angle, angle. And abbreviated, that is SAA, right? And again, we have, let's just draw a quick sketch of a diagram, or triangle rather. Let's draw these two triangles as such. And congruency is basically a copy and paste of triangle because it's identical in all respects. It's just the exact same triangle that's labeled differently. But we have to prove that it is in fact congruent to each other. So again, I'm not going to rotate it or orientate it differently. I just want to quickly show you a simple that it's simply equal to each other, or it's simply congruent to each other, and show you the proof for that. So I have, let's say I have triangle DEF, and I have triangle GHI. So I'm given this piece of information, and I'm required to prove that these two triangles are in fact congruent to each other. So here's my proof. Right, so I'm going to say I'm required to prove that triangle DEF is congruent to triangle GHI. Let's just stick with this one color for now. So let's write out our proof. Our proof is that in triangle DEF and triangle GHI, I observe the following. Right, the first thing I notice is that there's a pair of corresponding sides that are equal. I notice that DE is equal to GH because it's given in the diagram. Right, I also notice that there's two pairs of corresponding angles that are equal to each other. That angle D is equal to angle G and angle F is equal to angle I. So as angle D is equal to angle G, it's given. And lastly, angle F is equal to angle I. It is also given. So what can I conclude from all this? I can conclude that therefore triangle DEF is congruent to triangle GHI because of side angle. There's one pair of corresponding sides that are equal, and there's two pairs of corresponding angles that are equal to each other. So it's SAA. Now the last method of congruency has to do with the right angle triangle, which is quite interesting. And we will look at a lot of right angle triangles when you look at the theorem of Pythagoras specifically, because the theorem of Pythagoras applies to right angle triangles. So let's quickly answer this question, or let's quickly write this out. So we have the fourth method to prove congruency, which is right hypotenuse side. Right hypotenuse side, abbreviated as RHS. So I have a right angle triangle as such. Now I cannot assume this is a right angle triangle. Why? Because there is no 90 degrees indicated. A right angle triangle is right angled because it has one angle that is 90 degrees. So let's quickly indicate that here as well. So that's usually indicated with a block that looks something like that. Right, so I'm just going to draw this whole block like a small square block. Okay, something like that, right? So this indicates that this angle here is 90 degrees. So again, we need to prove that these two triangles are congruent. It's just a copy and paste. We have to prove that it is in fact a copy and paste of the first triangle. So I have two triangles, and let us prove it. So here I have the triangle on the left is triangle, let's keep it simple, triangle ABC. And the triangle on the right is triangle DEF. Right? So these two are right angle triangles. Now there's a very big word that some of you may not have heard, especially if you're from grade 8, is the word hypotenuse. And you might wonder, what is an hypotenuse? The hypotenuse, right? So let me quickly explain. A right angle triangle, like any other triangle, it has three sides. The hypotenuse is the longest length or the longest side in a right angled triangle. And you can find the hypotenuse by looking at the right angle. The side of the triangle that is opposite the 90 degrees angle is the hypotenuse. So if you look at triangle ABC, angle B is 90 degrees. So the side that is opposite 90 degrees is the hypotenuse. Right? So AC is the hypotenuse of the triangle. If I look at triangle DEF, I can see that the side that is opposite 90 degrees is DF, and DF is the hypotenuse in triangle DEF. So that is the hypotenuse. So now we have to prove that these two triangles are in fact congruent to each other, that they're basically identical to each other. So I'm given this information, right? I'm given this information and I'm required to prove. So I'm required to prove that triangle ABC is congruent to triangle DEF. And let's write out our proof as such. Okay, let's write out our proof as such. So the proof is that in triangle ABC and triangle DEF, I notice the following. Firstly, I notice that both triangles have an angle in common. Angle B is 90 degrees and angle E is 90 degrees. So I can say that angle B is equal to angle E. Why? Because they are both 90 degrees. So you can even say given 90 degrees, given that they're both 90 degrees. The second point that I notice is that the two respective hypotenuses are equal to each other. The hypotenuse of triangle ABC, which is AC, is marked as the same length as the hypotenuse in triangle DEF, right, which is DF. So we can say that the hypotenuse AC is equal to the hypotenuse DF, and we can say that it is given. It's marked on the diagram. And lastly, we can see that BC is equal, it's a random side, BC is equal to EF, and that is always given. Please note, whenever you see a right angle triangle, don't just assume that it's right hypotenuse side. If it follows the sequence of right hypotenuse side, that's great, then it is. But not in all cases. In this case, I can see it's right because both are 90 degrees, angle B and angle E, and they're equal to each other. And we can also see that the two hypotenuses are equal to each other. AC is equal to DF. And lastly, we can see that a pair of random sides are equal to each other. So that's S, a pair of sides are equal. So my final concluding remark is that therefore triangle ABC is similar, it's congruent, this is a sign for congruent, to triangle DEF, and the reason for that is right hypotenuse side. Right hypotenuse side. So just to conclude this short lesson that we had, or the summary of the lesson that we had, right? We looked at the 4 conditions of congruency. So to summarize, we looked at the 4 conditions of congruency. And please do not say angle, angle, angle to prove congruency. Angle, angle, angle is for similarity, right? So if we want to prove that 2 triangles are similar, we can prove that at least 2 corresponding angles are equal, and then of course the third angle is implied that it's equal because of the third angle of triangle. But for congruent triangle, there's 4 conditions. There's side, side, side. There's side, angle, side. There's side, angle, angle. And lastly, there's right hypotenuse side. Those are the 4 conditions to prove that 2 triangles are congruent to each other. So I thank you for watching this video.